Hey guys, let's refresh ourselves on some of the basics of trigs and solving triangles. This is going to lead into what we're going to do next week, where we're going to solve non-right triangles. So our basics of trig, all of it came from the relationship in a right triangle to one of the acute angles. And remember, it didn't matter which acute angle you worked with, that would just dictate how the sides were related to that one. So I'm going to choose to work with that angle theta. Now, with respect to that angle theta, we have two legs, and then we have the hypotenuse. There's only one hypotenuse, so we don't need to differentiate between that and the other hypotenuse, because that's the only one. So we have the hypotenuse, and then we have two legs. One of the legs is touching the angle, the other leg is not. This leg that's not, it's across in the triangle, it's opposite from the angle. So that's our opposite leg. And then the leg that's touching it, this is our adjacent leg. So every time we work with this relationship in the triangles, I'm going to use the abbreviation OPP for opposite, ADJ for adjacent, and HYP for hypotenuse. So if we have our right triangle with angle theta there, this side is opposite, this side is adjacent, and this side is our hypotenuse. There were 6 trig functions that we had. We had our 3 basic trig functions and then the reciprocals of those. The 3 basic trig functions were sine, cosine, and tangent. Remember, these abbreviations can never be by themselves. They have to have an angle attached to them. As they are, this means absolutely nothing. Remember, sine, cosine, and tangent have to have an angle with them. In this case, our angle is theta. And sine is defined as the ratio of the opposite side to the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse. And tangent is the opposite side to the adjacent side. The very common mnemonic device we have for this is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. So that's our standard, our basic trig functions, our basic trig ratios. We also have the reciprocal trig ratios. So if we have that same right triangle with theta there, we have our opposite, our adjacent, and our hypotenuse. The others are the reciprocals of sine, cosine, and tangent. So we have the reciprocal of sine, the reciprocal of cosine, and the reciprocal of tangent. So the reciprocal of sine, it is called cosecant. The reciprocal of cosine is called secant, and the reciprocal of tangent is called cotangent. So cosecant's the reciprocal of sine, so instead of opposite over hypotenuse, it's hypotenuse over opposite. Reciprocal of cosine is secant, so instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And reciprocal of tangent is cotangent, so instead of opposite over adjacent, it's adjacent over opposite. Unless you have a very, very advanced calculator, you're not going to have one with secant, cosecant, and cotangent on it. So we don't have a mnemonic device for these. These, you should remember these relationships. That cosecant's the reciprocal of sine, secant's the reciprocal of cosine, cotangent's the reciprocal of tangent. But almost every time we will be using these 3 as opposed to these 3. So if we have a triangle, just an arbitrary triangle, I'm going to call this triangle ABC, and I'm going to say that this is 6 and that's 10. If we wanted to do sine, cosine, tangent of one of the acute angles, so in this case I'm going to choose A, we need to know what the third side of the triangle is. And if we know two sides of a right triangle, we can use the Pythagorean theorem to find the third. So 6 squared plus b squared equals 10 squared. Subtract 36 from 100, you get 64. So that's just 8. So this 8 is opposite from A. So that's opposite from A. This 6 is adjacent to A, and this 10 is the hypotenuse. So sine of A is opposite over hypotenuse, 8 over 10, which is 4/5. Cosine of A is adjacent over hypotenuse, 6 over 10, is 3/5. And tangent of A is opposite over adjacent, 8 over 6, so 4/3. We could do the same thing, except with B, we could do sine of B, cosine of B, and tangent of B. Oh, sorry, not B, with C. B is the right angle. We're not going to do it with the right angle. So let's try this again. Sine of C, cosine of C, and tangent of C. So with C, with respect to C, the 10 is still the hypotenuse. That's good. But the 8 is no longer opposite. 8 is opposite A, it's not opposite C. What's opposite C is the adjacent. Is the 6. The adjacent of A is opposite C. It always goes back to which angle you're working with. So opposite C is 6, adjacent to C is 8. So sine, it's opposite over hypotenuse, 6 over 10, we already found that, is 3/5. Cosine is adjacent over hypotenuse. Adjacent to C is 8 over 10, that's 4/5. And tangent is opposite over adjacent, 6 over 8 is 3/4. All right, so that's the basics of trigonometry. We'll talk about solving right triangles using trig shortly, and then next week we'll talk about solving non-right triangles.